So today we're going to look at solving polynomial simultaneous equations. We are going to solve simultaneous equations. On the first two equations, you should be able to see. The first one is y equals to 4 minus x. The second one is y equals to x minus 4 squared plus 6. We're going to do it in two different ways. The first way is to use a calculator. The second way is to use graphs. And I'll show you both ways. So we're going to start with add a calculator. What I need you to do is to click onto menu, and because we are solving simultaneous, we need to look for simultaneous, which is on the algebra, solving system of equations, and then solving system of equations. Now, the bottom one says linear equations. Because we're doing polynomials, don't use linear equations, use the first one. We are solving for x and y, so we can leave it as x and y, and we have two equations. So the first one is y equals to 4 minus x. The second one is y equals to x minus 4 all squared plus 6. Now, one of three scenarios can happen, given that it is a quadratic. What are they? How many solutions can you possibly have with a quadratic with something else? 2, 1, or 0. If it says false, how many solutions do you think that is? 0. Okay? Let's do the second one. To quickly do it, you can just copy it. If you press up twice and then you press enter, it will actually quickly copy it for you. That will save you some time. So the second one is negative x squared plus 2x minus 7. And the bottom one we have is 2x plus 1, x minus 4, and x plus 2. Now, for my calculator settings, I've set it so that it would display exact values first. If it instantly displays decimals, that means there are no exact values. Yeah, it's irrational. And the way it's usually calculated, if there is no exact value, is it uses some numerical approach to figure it out. I'm not going to go through all of that. But make sure you press left and right by going up and checking your different answers here, so then you know what they are. It should be fairly straightforward. You just simply go through and you just write down what the answers are. In terms of your answers, please check what the question says. In methods, you will only usually ever get number of decimal places. For those of you who do further maths, you might be familiar, further maths, chemistry, not so much physics. You might be familiar with either scientific notation or what's the other one called? Significant figures. Okay? You don't usually ever see that in methods, so you don't usually need to worry about that. Just check if it says 2 decimal places, answer it with 2 decimal places. Just follow what it says. Is that clear? So we had a question earlier about why the first set of simultaneous equations we had, y equals to 4 minus x, and y equals to x minus 4 squared plus 6 doesn't have any solutions, or pops up as false. Graphs, and we can see what y. So we have 4 minus x, also x minus 4 squared plus 6. Now if we have a look closely here, the two graphs actually don't intersect, and because they don't intersect, you have no solution. Because the only way you can have solutions is if the two graphs have intersection points. So in terms of the remaining two questions, we can use it graphically to match what we have on the booklet. So x cubed plus 2x squared minus 19x plus 2. And the other graph was 100
can see there's only one point of intersection, and if on your graph you can't actually see the point of intersection, you can still just tell it to analyze graph, find the point of intersection, and it will automatically zoom in for you. So let me show you how that works. If you go on standard, you can't see that it crosses, but you can see there's a red line here and the blue part of a graph. Let me just show you. Analyze graph, intersection, and it automatically zooms in to the point of intersection for you. So the answer to the solution for C would be 4.6 and 54. And then D, you have x over 3 plus 10x squared plus 35x plus 2. Second one was 85 plus 23x. Now, it's a bit hard to see, so let's just zoom in a little bit so then we can see what's happening. So if you have a look here, that's about 10 for each little line, and you can see it's in between 10, so let's do something like 10. And so 10 to maybe 15 for the x-axis, and then for the y-axis you can see it goes up quite high, but it's 10 for each of these as well, so 10, 20, so you might want to do 30 for the bottom, and then for the top I'll show you what we can do with that. So -10, 20, 30. Alright, now you can see it's way higher than that, and if you kind of assume, if you kind of think about how the graph would work, it will curve up and then come back down. You can imagine it's a lot higher. So let's say we do something like 250 just to see the graph. Now, we can't see the last point yet. Technically, you can just zoom in bigger, but remember from before, we can actually just get the CAS calculator to automatically zoom in to find our points of intersection. So let's just do that. So analyze graph, intersection. There's the first one. We have the second one from when we did it before. Analyze graph, and then intersection here. And remember, it automatically zooms in, so then we have all 3 points of intersection.
Alright, so we're going to find points of intersection. This time around we're going to do it by hand. Whenever you are doing it by hand, you are using one of the things you would have learnt from simultaneous equations. Can anyone guess which one it is out of elimination and substitution? Substitution. So we simply need to make the two sections of what y is equal to each other. So -2x plus 4 equals x squared minus 8x plus 12. If you put everything on one side, you should be left with x squared minus 6x plus 8. So then, I'm not going to bore you with all the details. When you solve it, you should get x equals to 2 and 4. Now, once you've figured out your two values, what do you need to make sure that you do? But then you put it... Hang on. Okay, once you have your two values, what do you do? Good. Now, which one would you like to put it in? The first one or the second one? First one, why? Because it's easier. Always put it in the easier one. It should, remember, they're points of intersections. They should be the same point either way. Therefore, you can substitute it into either equation. So you put in the first one, it'll give you a 0. Put in the second number, x equals to 4. Negative 4, shouldn't it? Now, make sure you check what the question says. Sometimes it will just say determine the values of x and y such that these two equations are satisfied or whatever. In this particular one, it says find the points of intersection. Therefore, your answers must be in points form at the end. In coordinate form. Thank you. So you can't just write x. You can write x equals to 2, y equals to 0. That's acceptable. You should try and write it as 2, 0, like I have here. But if you just write the values of, say, x equals to 4, y equals to 0, for example, where it's not in the correct order, it will not be accepted. Okay? Make sure you write them as pairs of values because it says points of intersection. Same thing with the second one. Substitute them in. I'll skip ahead and just tell you it's x squared minus 4x. And so your two values are x equals to 0 and 4. You can check the written notes if you need to. Oops. Any questions in terms of that? Sorry if you're watching this later, you can't ask questions directly. Anyway. Alright, last slide. Show that the straight line y equals to 1 minus x meets the parabola y equals to x squared minus 3x plus 2 once only. If it only meets it once, how many solutions do you have? 1. And what's the thing that we can use for parabolas to check how many solutions you have? Discriminant. So, equate the two equations. Okay. So, option 1, as we said before, is using the discriminant. Okay, equals to 0, you have one solution. What's the other option that I have mentioned before, if you vaguely recall? If you have a look here, that is what type of, what can you factorize it using? Yeah, perfect squared. And because it's a perfect squared, yeah. Okay, so both are acceptable as long as you write down y. Alright, last one. For what values of m do the two lines, the line and the parabola intersect twice? So same thing as before, use your discriminant. rearrange your equations. And then here's where it gets a little bit messy. You are going to use your discriminant, which is the square of the middle one. There is a negative, but we don't have to write that. Why is that? Yeah, you're going to square the negative. Minus 4a and c. When you've expanded this out, hopefully I've done it right, you should be left with m squared minus 2m minus 7. We want intersecting twice, so what do we need that to be? Less than, equal, or greater than 0? Greater than 0. What's the best way to check that? Graphing it. Is it positive or negative? In front of m squared. Positive. So is it a positive parabola or negative parabola? If you use, so I use the quadratic equation to solve for the two solutions here. Which section is greater than 0? The top or the bottom? Top. So, what do we need it to do then? Yep. What's the first bit? To the left or to the right? Of the first one, which is 1 minus 2 root 2. To the left, point your arrow to the left. And the other one? Point it to the right. And then that's your work for today.